A few notes on syntax lang of pointers. We're going to use a simpler example and then we're going to go back to our structs example in a little while. But let's use a simple example just to talk about syntax of pointers. Okay, here's an int x, and then I'll assign int x a value of 5. Okay, so we have x, and x is an int, and its value is 5. All right. Now, here is an int pointer. So it has an int with an asterisk after it at the end, and let's call this x pointer. All right. All right, we'll compile this. Now, after we've declared both of these variables, what we're going to get is something that looks like this. So we'll have our x, and then it's a kind of box in memory, and the value of x is 5. All right? And then the numbers up here, these are dummy values. I don't actually know what the actual values are. But this is the address in memory of the variables that we have. So we have x, and the value of the address of x in memory is 243,523. And for x pointer, it's 243,520. So actually, memory, it's just a series of boxes. Series of boxes that are successive, one beside each other, and to identify which box your data is in, each box has a unique address. This is how the computer knows where to find the variables that you've stored, is by referring to its address. Yeah, I'm having trouble trying to get these lined up. So it will look something like that. I can get it to line up. Okay, something like that. So when your program runs, it puts all the data that your program needs in memory. So memory looks something like this. It's a series of boxes that can store values. Each of these boxes have individual addresses that the program can refer to find out what the value of the variable that you used is. So in this case, we have two boxes. We don't know exactly where in memory. We don't know exactly what their addresses are. Those are numbers that I made up. But I hope you get the idea that variables are stored in memory, and each memory location has a specific address so that the program knows where in memory to access this variable. Okay, now, so if we said printf %d backslash n x, we would expect to get 5. Okay, now what happens when we want to let x pointer refer to x? The way we would say it is, we would say x pointer is assigned the value of the address of x. Okay. What that means graphically is, so ang ampersand, the ampersand operator, it produces the address in memory specific to the variable x. So what happens is x pointer will be assigned the value of something like that, the value of x. Okay? All right. So let's see if this is true. Let's look at the diagram one more time. So get x pointer is now assigned the value of the address of x. All right, let's see if that's true. So if we said x, we should get 5. And if we said x pointer, we should get the address of x. Also, if we said address of x, we should get the same result as we said said for the next one. But we can't say int because it's int pointer. So let's say percent, I don't know, p. No. All right, here we go. So what we expect is this. We expect that the first thing that's printed is 5. The next two lines that are printed should have the same value. The first one we expect to be the address of x, and the second one we also expect to be the address of x. But now, this is the value of x pointer. Okay, so let's see that run. Running. Right, okay, so the address, it's given as some hex value. This doesn't matter, the exact value doesn't matter. This is just to illustrate that the value of x pointer is now the address of x. So address of x, value of x pointer, identical values. All right, so given x pointer, how then do we access the value of x? So now we said that x pointer is pointing to x. Let's put that arrow back up here. Here you go. So what this is saying is x pointer now points to x. That means we can access the value of x through x pointer. How do we access the value of x through x pointer? The way we say it is, let's say %d. The way we say it is, we say x pointer, but we use the dereferencing operator. So for example, the address operator is ampersand. The dereferencing operator is confusingly asterisk. All right. I think that's a bad choice of operator, but we're not designers of C. We'll come back to why that's confusing, why I think that's confusing in a little bit. But let's see what the results are. So do you see that whenever we use the dereferencing operator on the pointer, the value that's produced is the value of the variable that the pointer is pointing to. Okay? So address of x, we'll assign it to x pointer. If we print that out, we should get the address of x. But if we want to get the value pointed to by x pointer, we use the dereferencing operator, this, and then it should produce what value of x is. Okay, what if we change the value of x? We said x here, maybe after we've printed x. What if we change the value of x? So we've printed x already, and then we'll change the value to say 10. And then once again, we'll print the value not of x, but the value of being pointed to by x pointer, dereferenced x pointer. Let's see what comes out. So you see, the first time x is printed, it's printed with value 5 because that's what the value of x is. But then the next time the value of x is printed, we're printing it through x pointer and not through x directly. And now we get the updated value 10. All right, so notice, here's the potentially confusing part. The potentially confusing part is that asterisk then has kind of two meanings. When you use it in the declaration, it means that this variable is of type pointer int, right? But when you use it here in the print, what we're saying is, I want the value being pointed to by x pointer. So do you see? Asterisk is used in two different ways. It's easy not to be confused if you just think that whenever I declare a pointer, I need asterisk, and whenever I need to dereference, I need asterisk. Dereference is the term we use when we say we want to get the value being pointed to by the pointer. All right. Okay. So let's go back to our struct. Let's do that in the next video.